Okay, in part 2 of converting recurring decimals to fraction form, we're going to look at this. So in the previous video, we explained how to convert recurring decimals that all the decimal digits recur, right? So all the 0, 3, 7, all the decimals that come right after the ones place are recurring. But you could also get questions like this, where the first decimal digit doesn't recur, but only the second digit and onwards recur. So it's going to be 0.2333333. So the previous method wouldn't exactly work for this. So let's see how we would do it. So we're going to be converting 0.23 recurring into fraction form. And that's basically 0.2333 continuing, right? So how would we do this? Well, in the previous video for just normal recurring decimals where all the decimal digits are recurring, what we did was we made r is equal to 0.23, right? Let's see if the previous method would work for this, first of all. So, r is 0.23. Then we use this kind of glitch-like thing, right? Kind of feels like you're hacking the system. So we'd multiply by 10. And we get 10r is equal to, well, this moves over, right? So it's going to be 2.3 recurring, right? Which is basic. So this 2 moved over, so we have 2.3 recurring here, right? And basically, we have all our recurring digits on our, we have the 2 on our ones place. But we need to get rid of all the recurring digits as well, right? So let's try multiply by 10 once more. It's going to give us 100r is equal to 23.3 recurring, right? So another digit's moved over, but the 3 is still recurring. And if we multiply once more, we get 1000r is equal to 233.3 recurring. Another digit has moved over. And r was 0.23. So what we would have done was we would have minused r so that all the recurring digits on the right side of the thing would be gone. But we have an issue, right? The 2 doesn't recur. So there's no 2, 3 recurring here. So when we do minus r on both sides, we're going to get r equals 233 stays the same, right? But we have a 3 here instead. And we have a 0.23. So it's not going to get rid of all the recurring decimals. It's just going to keep going on and on and on. So this method that we used previously and would have worked for continuing where all the decimal digits recur, this method wouldn't work for this question here. So how would we solve something like this then? Let's start from the fresh again. So 0.23 recurring. So only the 2 is recurring, so I'll just rewrite this 2, 3, 3, 3, 3, and so on. So what would we do? Well, a similar process to what we did previously does also need to happen. So this would be 10r, right? So r is still going to equal 0.23 recurring, right? But there's a sort of different method we use. So 10r is 2.3 recurring, right? This 2 is moved over. So in a way, it's pretty much what we were doing before, 2.3 recurring. But if we minus r from this now, r was 0.23 recurring, right? If we minus this, that would give us 9r, because 10r, so that's minus 10r from r. It's going to give us r, right? 10r minus r is going to give us 9r. And this 2 minus 0, that's going to give us nothing, so it's going to stay as 2. Now we have a recurring 3 here. So this can be written as 2.333 recurring. And we have this over here as 0.233 recurring. What happens when you minus this? So we have 2 here. 3 minus 2 is 1, right? And all these 3's are recurring continuously, right? So there's going to be 2.13 recurring. But what do you notice? This 3 minuses this, so it becomes 1. But the rest of the 3's continue to occur. And these are minusing, so these will all cancel them out. It's sort of a glitch again. So this will not exist. It's just going to be 9r is equal to 2.1. And what does that mean? We can divide by 9 on both sides to give us r is equal to 2.1 divided by 9. Let's make this a bit easier. So 21 over 90. And in the previous video, I just gave you guys the answer for this. 0.23, no, I didn't. I'm thinking of something else. Anyways, 24 over 90. We can simplify this by dividing by 3 on both sides. So that's going to give us 7. and divide by 3 here is going to be 7 over 30. So our final answer is 7 over 30. Now, I know you guys might be confused right now, so I'll go over this one more time. So we started with a recurring decimal that not all the digits recur. So it's 0.23, but only the 3 recurs. We tried the previous method where you multiply and you minus all the decimal digits, right? But that wouldn't work because the decimal digits, the 2 doesn't recur, so you can't really minus it. But when you have 0.23 recurring and 0.233333, right? So R, you start off the same way as before. So R is going to equal 0.23 recurring, right? Which can be written like so. When you multiply by 10, we're going to get 10R is equal to 2.3 recurring, right? So 2.33333 recurring, right? So on and so forth. And R is 0.23 recurring, right? So 10R was 2.3 because we multiplied 0.23 by 10. So this would go on forever. And R was 0.23333 recurring. That was the original number, and we multiplied the original number by 10 to give us this, 2.333, right? So this is 10R minus R. Well, this 2 minus 0 is going to give us 2. But 3 minus 2, well, that's going to give us 1. And all these remaining recurring digits, they will continue to get cancelled out by the R below it, right? So that just gives us 2.1 is equal to 9R. Well, now it's just simple algebra. R equals 2.1 divided by 9. You multiply by 10 to make 21 over 90 because we don't want a decimal as a numerator, right? And 21 over 90 can be divided by 3 on both sides, so 7 over 30. That's it. I hope this helped you, and I'll see you guys in the next one.